Good morning. Hello, everyone. Thank you, Maria, for a very good introduction. Okay. Okay. So, as Maria mentioned, I want to show you some presentation about effective mobility data collection. I have some experience, and I would like to share with you some basic things and some maybe practical things we will see. Of course, I think we know that we need the data to plan the mobility. The data is very important. Without the data, I think we could just dreaming or imagining the future and the reality. So at first, I think we need that data to understand trivial behavior. It's the most important thing, because we would like to prepare some plans, some documents for residents, and we should have some information about how they travel behavior looks, and maybe how it will be in the future. So it is the most important part. The ideal situation is when we have a monitoring system which lets us collect the data in real time. But of course, it depends on the system, for example, of public transport management system, that what you have or about or from ITS system. So it creates some costs. So we should finding data from the another sources. Why we need that data in the other cases? It's important to evaluate our policy effectiveness. So we are preparing some SUMP, for examples, and especially in the context of SUMP, this type of documents should be included a structured system and a clear methodology for monitoring the effects or implemented measures using measurable indicators, rather than relying on general trends, I think. So the monitoring methodology should be based on reliable and accessible data sources. And of course, what data we will discuss it. And when we planning something for the future, so we create some tasks in SUMP documents. We should have some maybe evidence what will be the results of that task. And to do that, we could just assume, or we could do some calculation based, for example, on some models, transport models, traffic models, forecasts models, and etc. But of course, we need some data to do that. And now we have really great times when we could collect that data from very different sources. We have traditional data sources like household travel surveys, which is, I think, it is the best source about travels which are realized from our residents. Of course, we could do traffic counts, passenger counts, or just we can use statistical data. But also we have some new data sources like mobile phone data, GPS, and floating car data, where we could identify on which part of our road network we have traffic junctions and the wasting of time and etc. The ticketing system, especially if we have a modern system of public transport, of course we could have ITS sensors. Maybe something totally new is bank card data, especially when we want to consider the trips for longer the distance. On this screen, I can show you some data, which, for example, we collected for our region in the previous year and also for 5 years ago. It's data from mobile phones, and it also let us to collect information from where to where people want to travel every day. But from the other hand, more data, it doesn't mean that our analysis will be better. There are several key challenges that analysts need to navigate. First, incomplete data sets. We often have missing segments of time periods, which create gaps in our understanding and can lead to an incomplete picture, especially when, for example, we do we collect the data from the spring, so we don't have information from the summer. The second, sampling weaknesses. If the data is not representative, it can distort results and lead to misleading conclusions. Third, incorrect interpretation. Sometimes the issue isn't the data itself, but how we interpret it. So we should understand what the data is actually represents and measures. The inconsistent methodologies, different data collection method can make comparisons difficult and reduce the reliability of conclusion. And finally, lack of validation, which is also important. I will show you on the next slides on some example, because using unverified data without proper quality checks or cross-validation increases the risk of mistakes, of errors. So overall, the key takeaways is to having the data is to understand that having the data is valuable, but without quality, consistency, and proper interpretation, it doesn't necessarily improve decision making. So, but if we have many data sources, I think it's a very good situation. For example, if we want to collect data from ticketing system, it's good idea also to collect data from traffic counts. So we have information from two modes of system. The best example is when we want to collect data from mobile phone. It's also very useful, and now it's popular. But that database don't have a full information about for example, motivation of trips. So I think it's a good idea to combine that with travel surveys. So it also let us to do some cross validation and finding maybe some errors about that data. On the next slide, I will show you how I do some cross-validation between mobile phone data and traffic counts, because some years ago we bought data from mobile provider who tried to sell us data with many basic mistakes. For example, you can see the disproportion about the number of trips from this one direction to the opposite direction, but this data is for whole day, so it's totally unlogical that people starts their trips at the morning here and finish maybe here, and they leave for the night, and that's a big disproportion. Of course, it's an error. It's not possible. And also, I decided that this database is wrong, because we also did some traffic counts screen from trains and cars. So we could compare the data from traffic counts and also from mobile data, and we can prove that this data is really bad. So what we can do else? As an engineer, methodology is the most important aspect for me. So a key element is understanding the method used to collect the data. For example, what is the sample? What was the measurement conducted? What or who was studied? What questions were asked? What are the source data? Additionally, it's important to be aware of the limitation and of a given data source. I think it's a very important challenges to understand that what we want to collect, what we want to buy, and etc. For example, if we discuss the mobile phone data, it provides excellent origin destination flows, but for example, we don't have good information about mode choice, and also we have big changes in reliability, extrapolating the sample to the population. If we procure a data delivery service, we should also obtain the detailed information about the methodology used to collect and process the data. The ideal situation is when we, as the contracting authority, define and impose the methodology also ourselves. But sometimes we don't have enough knowledge, so it could be difficult. If we collect the data by ourselves, it is important to clean the data by removing anomalies, or missing values, and checking the data accuracy. As I have just shown in this previous example, it is also crucial to validate the data logically and compare it with data from other sources. This allows us to build a comprehensive picture of and ensure that the data are reliable. So about some basics, I think we understand that we try to make some summaries, some results of our analysis. We should understand that we should looking for what is the reason of that results. Because, for example, like we have on this slide, when we noticed the increase of public transport ridership, it could be many reasons why we have that situation. It could be service quality improvement, or maybe some other things like fuel prices increased, or population is bigger, is growing. So I would like to emphasize that we should rely on not a single data sets. As I showed you, it's a good idea to combine that data, validate that data with other sources. Because every source has some weakness. For example, as I mentioned, also the mobile phone data is a problem it could be a problem for us, because the operator has varying market shares across different regions, which makes it difficult to extrapolate the sample to the population. In ticket data, we have often problem to convert the number of trips from monthly tickets into the actual number of journeys. And in our Pomeranian region from Poland, we don't have usual information from where to where. We know how many passengers we have, but maybe we don't have information from ticketing system where the trips beginning and where is the destination. So key takeaways is some summary of my presentation. We should the good idea is to combine multiple sources. From my point of view and my experience, we should understand how the data has been collected. And we should validate every part of data which we buying or making or collecting. Interpretation is maybe another problem, but it's also important to understand what was the other what's the results of our analysis, and if you want to use some models to do some additional analysis, we should do that responsibility. Now we have many sources of the data, but it's not a problem to buy that data. The problem is to do our analysis with full competence, with full and understanding. And usually we need some expert to do that if we are not an expert. And at the end, I could show you some examples because I know we have some workshops about that. Maybe it's important. Maybe it could be interesting for you to collect data from Bluetooth about the walk traffic, the pedestrians or bikes, because we could do that by the new technology with using a Bluetooth sensors or Wi-Fi sensors, so we can connect this stuff to some mobile, etc. But we have, of course, many sources that I could describe every of that, but we don't have enough time, I think. So thank you very much for the time for me.
Some lessons learned from our pilot projects on the Schoolhood project, and we actually also did some collaboration with SUMPs for BSR Mobility Hub pilot, and you will learn about that too. So just to make the long story short, our pilot school was this kind of one school was closed, and about 200 pupils was relocated to another school, which was our pilot school. And so there was a big change in traffic environment for these 200 pupils plus employees, of course. We also had some pre-data. We did some geospatial analysis, and we figured out that almost all of the students and the pupils live less than 2 kilometers away from the school, actually. So we kind of could make the assumption that the escorting traffic wouldn't be a problem. But we proved ourselves wrong as the school started. We did some preparative measures also, like some informational days for the parents of the new school. We had some more soft measures, teaching children some cycling and traffic skills. We had some campaigns also along the way. But none of these soft measures proved to be effective enough, or we didn't get the results like quick enough, and the traffic environment actually was really dangerous. There was a lot of car traffic in front of the school. We got a lot of complaints from the neighborhoods and from the parents and from the school and so forth. So we needed to make some new plans. We did the planning in close collaboration with the residents of the area, and we had traffic planners and variety of city employees as well planning the pilot. So here's just shortly to show you what our traffic calming pilot was about. So there was a lot of traffic in front of the school, I don't know if you can see my pointer. Now you maybe see it. So this is the school, and there was a loads of traffic, and perception of safety was very low. So what we did, we tried to inform the parents that they could also leave their children here. It's just a 5-minute safe walk to school from here. So we restricted the car traffics on certain streets. We put some physical barriers, also brought some greenery over there. We did also some smaller arrangements on the parking in front of the school. Then we also implemented the mobility hub near to the school to give, of course, alternative options for car driving. Here, yeah, but we like knew that there would be a lot of opposition for this kind of a pilot due to making restrictions for the car drivers, for especially the residents living on the eastern side of the roadblocks. We couldn't block the whole street in front of the school because this was the only way out from the area. Okay, so because we knew that would be very much oppositions, so we had to make very precise and thorough evaluation plan to see how it actually goes and does it have effect. So here's also the mobility hub pointed out with e-cargo bikes and city bikes, bus stop, e-scooters, and so forth. And here's the kiss and ride spot. Okay, so we knew that we would need a lot of data to get this very, very controversial measure to get continuum as well if it was successful. So what we did, we had some traffic counting in the baseline and also in the follow-up. We had it in several intersections and for several months. So we could actually see if there's some change. We also did this map-based survey for the residents, for the pupils, for the school and other stakeholders, where we wanted to find out the perception of safety, the attitudes toward this kind of pilot, of course also the perception of the pilot's effects on their modal splits, but also we asked for their perception on the effects of the pilot on a map, if there would be some spots that feels more unsafe or so forth. We had a good talk with the student council, which is the representatives kind of from the pupils of the school, because we wanted to highlight their opinion as well, how it feels during the pilot, the school route. We had also surveillance on site, also drone videos to see the traffic flow. We could make some calculations there as well. And then in the end, we had this public hearing for the residents of the neighborhood where they could actually kind of decide what we are going to do in the end. So the result actually was that the Urban Environment Board approved this pilot to continue at least until another school pupils move back to their old school. We also are continuing still our evaluation, even though this is no longer a project-based pilot, but it's now ongoing for a certain time. But we are still doing the evaluation because we will make the new decision-making round in 2 years or so. And we also need to see the effects on winter time mobility, which we didn't have chance on last August to November period. Okay, but here is also a couple of clips from the map-based survey where we can see people's opinions, where we ask, for example, in these pictures, their perceptions of where there is more cars now during the pilot, the blue dots. And where they could see less cars than before the pilot, and these are the less cars is the green dots. So you can also see here that it's very controversial results. It's the same street with more cars or less cars. So we of course compared this to our traffic calculations, and actually the green cars seemed more accurate. This is also something on the kind of like I mentioned maybe trustworthy data. So we wanted to see the sample size of residents replying to the survey. So we made this analysis who has replied to the survey. Here are some more cons and pros, but just shortly, we actually were able to increase the perception of safety. Also, the walking and cycling share of it actually increased a lot. The attitudes, they were kind of split, whether we should continue with the pilot or not. But you can go through this more precisely when you get the slides. I won't go through them more, but a bit about the lessons learned. Maybe the most important thing is that we need to have, with this kind of very controversial measures and very kind of risky measures where we know that there's a lot of restricting of cars and so forth. So we need to have here the attitudes and perceptions and calculations and combine them both to make the final decision. And I don't think that without this very thorough evaluation, I don't think we would have had the chance for the continuum of the pilot, because the residents who were unhappy were also very loud with their unhappiness. But we could prove that this pilot had, in the end, a good effect and the effect that we wanted. Here are some more thoughts, but maybe I will highlight this lastly, that combination of these soft measures and infrastructural measures is very important in two ways. First of all, we can have the attitudes are much easier if we have the evidence that we have tried out actually first all of these soft measures before making any restrictions. And then also, on the other hand, it is very important that we offer some choice for different possibilities if we restrict one mode of transportation. In this case, it was the mobility hub. But also we, of course, needed to raise the skills of children to actually walk or ride a bicycle in the traffic. So this is a long story made short. Thank you.
Hello, everyone. Thank you for the introduction. My name is Justyna Suchanek, and as Maria said, I represent the city of Gdynia. And today I would like to share a short story from our work, from our pilot, from our SUMPs for BSR project with school mobility, and how we used an AI camera using machine learning system as one of data sources in our active mobility increasing through the last 2 years. It's not maybe a large project, it's some pilot time, I think, but it helped us better understand how students actually move in the city to school, and in practice that turned out to be more complex than we expected, I think. And now we started from a very basic problem. We didn't really know how students aged from 16 to 19 actually travel to school in everyday conditions. we were missing data on walking, cycling, and also we didn't have the data from car drop-offs. And I think this is our basic point that we had more than 2 years ago. And the data we had was too general, not up to date, and mostly based on declarations, and not the real data, So, for example, we could say how many students declare they cycle, but we didn't know exactly if they actually do it every day, or only when the weather is good, or maybe it's the one per month or something like that. It's only the declaration form. It's not the real data for the real decision and for real decisions also. And this difference matters if you want to design the real solutions in the city. So we had the information, but we didn't really understand the behavior of this part of stakeholders that we have in the city. And why schools? We choose schools because they create a very specific situation in the city. There is a high concentration of trips, clear peak hours in the morning and afternoon, and a mix of different travel modes. Everything happens at the same time and in one place. And when you look at it from a city perspective, it's almost like a natural places laboratory for us to do it something with the data because we want to increasing active mobility, and we've had a lot of campaign for kids, for the people who work, but we didn't right now we have the campaign also for the students, but this is the result of our pilot, of our collecting the data from the schools. And when you look it from a city perspective, it's almost like a good place to collect the data, and you can observe how different users interact in a relatively small spaces in the city. So it's a very good environment to understand real mobility patterns that we think, and we choose this kind of area for our development, the pilot, and the data collection. Instead of choosing one method, we combine several methods. We use citywide surveys. We've had workshops in selected schools, interview with some students, campaign data from an app. We've had the city active cities. This is the special app for collecting the trips, and also the automated monitoring using AI camera. Not because we want to only to test technology, but we want to combine the real data and the declaration from the students. And this is the important to combine the quantitative data and qualitative data together. Because one source of data was simply, for us right now, not enough, and each method shows something different for us. Because surveys show intentions, workshops show context, why students choose this kind of transport, and campaign data shows engagement, and AI shows what actually happens in this crosswords near the school. And only when you put this together, you start to see something consistent, something clear, and something wider than before. This is our idea. And then we moved to real conditions. We selected a location close to a school, and from the beginning, only one location where mobility intensity is high. And we installed an AI camera in a real street environment. not only in a model, not in a simulation time, but we monitor movement during morning and afternoon peaks in this area, and the data was automatically processed to detect modes and counts flows, and we've had the special dashboard with the concrete number, and so this was happening in normal city conditions with all the variability that comes with it, and we know that it's the real time and real city and real data from this time. This is what we observed at the intersection that we're choosing. Intensive pedestrian crossings, car-dominated traffic flows, and many conflicting movements between pedestrians and cyclists, and also the car movements, a lot of kind of modes. It's here in this intersection. And you can clearly see peak hour congestion. And if you look at this situation for a moment, you can imagine what it feels like for a student trying to cross this intersection every morning to the school. I think it's not only just about numbers, because it's important, but I think this is the importance in combine the the students' motivation and also the data. But it's about how space is actually used and how different movements overlap right now, and this becomes much, I think, clearer for us, and when you see the real data, because it's not only the subjective opinions that you didn't see the pedestrian in one moment every day, but we can analyze the data from 24 hours, 7 days per week, and I think this is the real plus for us. One important thing, I think, is that we didn't look at just one moment. We monitored continuously, and this changes how you understand mobility, because patterns shift during the day and also between days, and we can compare the data from the different periods, and we know that it's very important. And for example, morning traffic looks different than afternoon traffic. And these differences are important when you think about interventions, when you think about the safety, when you think about the investment. And again, some of these patterns are simply not visible in surveys. We see it only in the data, in the real data. And from this work, a few things became very clear for us after the pilot experience. First, the biggest challenge is not only collecting the data, it's combining, because when you bring together surveys, AI counts, campaign data, when you talk with students, with teachers, with family, it requires more work than expected. And we actually experienced that that data without the structure quickly becomes difficult to use. And second, AI gives you data, but not answers, I think. Automated counts still need calibration, validation, context, and checking that everything is fine in collecting the data, and we use it in the right way. And it's very complicated, I think, right now, because it's new technology, and we don't. I think it's not the perfect solution right now, but maybe for like the 5 years or maybe more, we can something better than we've had right now. But it's better than the manual surveys, I think, and subjective opinions. Third, behavior and technology need to work together, I think, because campaigns can influence habits, but AI shows what actually happens in reality, and you need both perspectives. And finally, schools are not just participants, they need to be partners in our project. Early engagement, cooperation with our stakeholders, and fitting into the school context made a big difference for us and for success of the project and changing the students' behavior. And the last one, based on this experience, a few maybe practical things for another cities. Start small, but choose the right place for AI camera, somewhere where you really don't understand what is happening, because in our case, choosing one specific location made everything much clearer for us. And don't start from technology. Start from a question you need to answer, because this is the important why you use it, and what you why you need the data, and what do you plan to use it after the data collection, and what is the purpose of the collecting the data. Otherwise, you risk collecting data that you don't really use later, involve people inside your organization early, because data alone doesn't lead to decisions. When we've had only the data, it's not the political decision. Make sure you plan time for analyzing the data also and collecting data. Collecting data is the easy part. Understanding it takes much longer. And I think treat us as a process, because test it, adjust, and only then think about scaling the experiments, because this is the important, to test something and then to implement this solution to another section in the city. The two slides more, it's only the photos from our campaign for students. This is how we work with schools during the campaign. This not only about data, collecting the data, we also worked with students, talk to them, try to understand their everyday choices, and a lot of talking, and try to understand the behavior, and choosing the mode of transport to school. Because without that, I think data alone wouldn't be enough, and that's not enough for the solution. And the last, AI visuals, and here you can see examples of our outputs, how different modes are detected, how movements are tracked, and how the space is used. This gives a much more detailed picture than traditional methods that we've had before the AI solution, and it helps us see things that would otherwise stay unnoticed before the project, because we've had only the manual data with the manual surveys before it. And thank you very much for the presentation. Thank you.